Hello everyone, in this video I'm going to explain questions about equations of motion, grade 11, unit 2, kinematics. That are the equations of motions that we can use. We have four equations. Each equation has four unknowns. Which equation we can use it depends on the given of the question. Let us start question number one. In question number one, he said a car accelerates uniformly. Then this is acceleration. From rest, the initial velocity equals 0 to 6.6. This is the final velocity. Then the given is the initial velocity, which is 0. The final velocity v equals 6.6 meter per second. In 6.5 seconds, this is the time. So the time is 6.5 seconds. Find the distance. Here the distance or displacement are the same because we talk about one direction. Then we need S. Now we think of the formula that contains V, U, T, and S. The equation that we can use is S equals half T multiply V plus U. Or we can rewrite it as U plus V over 2 multiplied by T. The same. Now substitute. So S equals half multiply the time, which is 6.5, multiply open bracket. V plus U, V is 6.6 plus U is 0. The answer is 21.45. The unit is meter. Next question. A car enters the freeway with a speed. Enter with a speed. Then this is the initial velocity. 6.4 meter per second. And accelerates uniformly. Accelerates uniformly for 3.2 kilometer. Then we have the displacement. 3.2 kilometer. We have to convert to meter. Then it's 3.2 multiply 10 power 3 to be in meter. In 3.5 minutes, this is the time. 3.5 minutes, we have to convert to second. 3.5 multiplied by 60. So the time is 210 seconds. How fast is the car moving after this time? We need the final velocity. Also here we have V, U, S, and T. Then we use the same formula. So the formula is that S equals U plus V over 2 multiply T. From this, we arrange it. Then we can multiply by 2 both sides to cancel 2 from the denominator. Multiply by 2. Then cancel this 2 with 2. Then from this formula, we can say U plus V equals 2S over T. Remember, we cancel the 2 with 2 beside T. Now we do substitution. So U is 6.4 plus V, V is the required, equals 2 multiply S, the displacement, which is 3.2 times 10 to the power 3, divided by the time in second, 210. We calculate this. The answer is 30.48. I round the answer to two decimal places. How can we get V? Just shift 6.4 to the other side. Then V equals 30.48 minus 6.4. 20.08. The unit of velocity is meter per second. Question number 3. A car with an initial speed, so this is u, accelerates at uniform rate, this is the acceleration, for 3.6, so this is the time. Find the final speed, we need v, and the displacement of the car. Then the given are, the givens are u equals 6.5 meter per second, the acceleration 0.92 meter per second squared, the time 3.6 seconds. What do we need? We need the final velocity and also the displacement. V equals u plus 80. So the formula that we can use is V equals u plus 80. We need V, then we do substitution. So V equals u is 6.5 plus a 0.92 multiply the time 3.6. We use the calculator to get the answer. The answer is 9.81 meter per second. I rounded the answer to two decimal places. Find the displacement. In physics, it's better to do not depend on your answer. So don't depend on this answer because two reasons. Maybe this answer is wrong. The second reason, it's not exact value. It's rounded value. It is approximation value. Now, UAT and we need S. So S equals UT plus half AT squared. Substitute. U equals 6.5 multiply 3.6 plus half multiply A 0.92 multiply T squared open bracket 3.6 squared. We use the calculator to get the answer. The answer is 29.36 meter. Next question. A car accelerates uniformly in a straight line. So here we have acceleration, then we use the formula, one formula for the uniform acceleration. From rest, then this is the initial velocity. At rate, from the unit, we can decide its acceleration. What is the speed of the car? We need the final. After it has traveled 55 meters, this is S. Then the given is u equals 0. The acceleration 2.3 meter per second squared. We need the velocity and the given also is S, 55 meter. Let us we go back to the equations of motion. Now, we have UAS and we need V. UAS and V. Then the last one. The formula that we can use is V squared equals U squared plus 2AS. Substitute. V squared is the required. U is 0. 0 squared plus 2 multiply A 2.3 multiply S 55. We use the calculator to get the answer. The answer is 253. This is V squared. Then V equals square root. We take the positive because it's in one direction. 253. So the answer approximately is 15.91 meter per second. Now, what about part B? How long? So we need the time. Does it take to travel 55 meters? Then we have the same given here. We have U, A, S, and we need T. Then we use what? The second formula. Then the formula that we can use is that. Okay? S equals U T plus half A T squared. So this is the formula that we can use. The best one. Now we do substitution. S equals 55, U equals 0, multiply T plus half multiply A, 2.3, multiply T squared. Then 55 equals 0 times T is 0, half multiply 2.3, it's 1.15 T squared. To get T squared, divide both sides by 1.15. To cancel this, then we can get T squared. So T squared equal 55 over 1.15. So the answer is 47.83. In each step, I round it to two decimal places. This is T squared. You need T. Also, we take the positive value. We don't write plus or minus because T must be positive. 47.83. Then square root of the answer. So the time is 6.92 seconds. So the time is 6.92 seconds. Next question. A cheetah starts from rest, then the initial velocity is 0 and accelerates at. From the unit, this is the acceleration. Due to is for 10 seconds, this is the time. Calculate the final velocity. Then the givens are u equals 0, acceleration is 2 meter per second squared, the time is 10 seconds, and in part A, we need V. Now, which formula use it? So in part A, the best formula that we can use is V equals U plus 80. Substitute. U equals 0 plus A, it's 2, multiply 10. 20 meter per second. In part B, it said the distance covers in 10 seconds. We need S. Also, try to depend on the givens. TAU, we need S. What is the best formula for S? The best formula for S equals UT plus half AT squared. Substitute. U equals 0, multiply 10, plus half, multiply A, which is 2, multiply 10 squared. We use the calculator to get the answer. The answer is 100 meters. An athlete accelerates out of hair blocks. Hair blocks, it means start from 0. The initial velocity is 0, start from rest, and the acceleration is 5 meter per second squared. How long? Then we need the time to run the first 10 meter. then S equals 10 meter. Now think of the best formula for this one. What is the best formula? We have U, A, S, and we need T. Then the best formula is that S equals UT plus half A T squared. Substitute S equals 10, U equals 0, multiply T plus half, multiply A5, multiply T squared. Simplify. 0 times T, it is 0. Half multiply 5, 2.5, then 2.5 T squared. To get T, we need to divide by 2.5 both sides to cancel this. Then from this equation, we can get T squared. It's 10 divided by 2.5. It's 4. Now, take the square root. Because the time must be positive, we take the positive square root of 4, which is 2 seconds. Now, part B. What is here velocity at this point? We need the final velocity. Also, try to depend on your answer. U, A, and S, and we need V. Then the formula that we can use it is V squared equals U squared plus 2AS. Substitute. U is 0, so 0 squared plus 2 multiply A 5 multiply S 10. 0 squared is 0, 2 times 5, 10 times 10, it's 100. This is V squared because the motion in one direction, we take the positive value of square root of 100, which is 10 meter per second. Now, next question, a runner accelerates from rest. Then the initial velocity is 0 at 3.4 meter per second squared. So this is the acceleration for 3 seconds. This is the time. She then maintains a steady velocity or steady velocity. It means the acceleration equals 0 for the rest of 100 meter. The rest of 100 meter. Now, remember, we have two cases. In case of uniform acceleration or constant acceleration, and another case, uniform velocity. Uniform acceleration or constant acceleration, we use one of the 3 or 4 formulae. V equals U plus AT, S equals UT plus half AT squared, V squared equals U squared plus 2AS. Finally, S equals U plus V over 2 multiply T. But if we said steady speed or constant speed, we use just one formula, V equals S over T. We can't use any one of the 4 first formulae. Now, it's a good idea. He said, how far does she travel during the acceleration? Now, it's a good idea to draw a straight line. This is the way of direction. Now, at the beginning starts from rest. So the initial velocity, the first one, equals 0. At 3.443 seconds, then this one, the acceleration of this interval is 3.4 meter per second squared for 3 seconds, and the time of this is 3 seconds. she got velocity. So this is the initial point O, and this is A, and this is finally, this is B. He said she then maintains a steady speed. Then in the first interval, in the first interval from 0 to A, it is uniform acceleration. So in the first one, it's uniform acceleration. In the second one, it is a steady speed. So it is uniform velocity. I said the total for the rest of 100 meter. Then the total distance from O to A, the total is 100 centimeter, or 100 meter. So the total distance between O and B is 100 meter. Now part A, I said how far does she travel during acceleration? Then in the interval OA. What are the givens in that interval? The givens are the initial velocity equals 0, the time equals 3 seconds, and the acceleration 3.4 meter per second squared. What do we need in that? How far? We need the displacement. Now, which formula we use it? Yes, S equals ut plus half at squared. Then use this formula. S equals ut plus half at squared. Now substitute. U equals 0 multiply 3 plus half multiply a 3.4 multiply 3 squared. The answer is 15.3 meter. Then in the first part in OA, okay, she traveled 15.3 meter. Then we can get the rest. The total is 100. Then the rest is 100 minus 15.3. It's 84.7 meter. What velocity does she reach? We need the velocity at A. We have U, T, and A. We need the velocity. Then the velocity at A is U plus AT. Substitute. U equals 0 plus A 3.4 and the time is 3. The answer is 10.2 meter per second. Then the velocity at A equals 10.2 meter per second. He said she maintains a steady velocity. Then the velocity from A to B, it's constant, which is 10.2 meter per second. How long in total does she take to run 100 meters? The time in the first interval already is 3. Now we need the time in the second interval. Then we talk about the interval in part C. We talk about the interval AB. What do we have in that interval? It is uniform velocity. We have here the velocity as given. The velocity is 10.2 meter per second. And also we have the displacement 84.7 meter. Then we use the formula for steady speed. V equals S over T. Then the time in that We can say this is T1. So the time equals S over V. S is the displacement in that interval, which is 84.7 divided by V, which is 10.2. The answer is 8.30 seconds. Then what is the total time? So the total time, how long in total does she take to run 100 meters? Then the total time T equals T1 plus T2. T1 it was 3 seconds and T2 we calculated it 8.3. The answer is 11.3 seconds.